Aspirin is one of the most commonly used medications right now. What's interesting about aspirin is not only its use for human beings in medication, but also its structure. It's interesting because the structure of aspirin is very similar to another chemical, methyl salicylate, also known as wintergreen, in gum, candies, medication, and other things. Wintergreen is a compound in oil found in many different types of plants. The similarities between wintergreen and aspirin are an ester. These groups are called esters. Here we have what's called a carboxylic acid. And here we have an alcohol. Both of these structures are actually based off of another chemical called salicylic acid. Now, we're not going to talk about salicylic acid, but it is important to know that these two are derivatives of salicylic acid. Now, how do we turn aspirin into wintergreen? What we have to do is one reaction, but what takes place is two different mechanisms. They are Fischer esterification and trans esterification. Both of these, I won't go into details as far as the mechanism is concerned, but what they do is this. Here's what we need to do to turn this aspirin into wintergreen. We must convert this carboxylic acid into an ester. We also must convert this ester into an alcohol. And this is where Fischer esterification comes in. And another term, trans esterification. Fischer esterification will turn something into an ester. Trans esterification will produce an ester, but in this case, it will turn an ester into an alcohol, which is our desired product for that part of the reaction. This all takes place under acidic conditions, where we use methanol, 2 portions of methanol, with sulfuric acid. These conditions will allow us to transform our carboxylic acid into an ester and our ester into an alcohol. Another part of this interesting piece of chemistry is not only these reaction conditions that we see here, but also the properties of wintergreen. One of the coolest properties I found is triboluminescence, which is basically you crush or mash a compound and light is a byproduct of that crushing. And as you can see here, someone's taking a hammer to some lifesavers, and we see that they glow in the dark. Methyl salicylate is also used in our food and as a medication, but it's in different concentrations. In food, It's in a low concentration. That's what gives us the minty flavors, the gum, the candy, and other things. In a high concentration, it provides more medicinal benefits, being an analgesic, namely in Bengay, and an antiseptic in Listerine. Let's review. Aspirin, the chemical that we know and love, can be converted under acidic conditions into wintergreen, the chemical that flavors gum, candies, also the chemical that is present in medications used for skin irritation and other things, and pain. It is an oil found in many different plants, and chemists can convert aspirin into wintergreen using processes called Fischer esterification, making an ester, this molecule, from a carboxylic acid, which is this molecule, and trans esterification, turning this ester into an alcohol. This is what converts aspirin into wintergreen. Then we talked about some of the properties of wintergreen, the triboluminescence. You crush and mass this product. Light is a byproduct. We talked about its concentration in food, and in a high concentration, how useful it is for our medications and for our breath smelling good. Again, this is another amazing example of how useful organic chemistry can be in everyday life. I hope you enjoyed it.